Hello, everyone, and thank you for joining this presentation. Our study is titled Online Learning and Local Teaching, Designing Culturally Relevant Mathematics Tasks Across Diverse Contexts. This research examines how two secondary mathematics teachers enrolled in a fully online master's program in mathematics education designed and implemented culturally relevant and cognitively demanding mathematics tasks within two different teaching contexts, one rural and one urban. In particular, this study explores how online teacher education environments, supported by peer feedback, digital collaboration, and emerging AI assisted planning tools, can help teachers design mathematics tasks in context and connect mathematical reasoning to students' lived experiences while maintaining strong cognitive demand. Mathematics classrooms are often criticized for presenting mathematics as abstract and disconnected from students' real lives. However, culturally relevant pedagogy, introduced by Lansing Billings, emphasized that effective teaching should connect academic learning to students' cultural identities, community experiences, and lived realities. In mathematics education, this means designing tasks that move beyond procedural practice and instead invite students to apply mathematical reasoning to meaningful real-world situations. Despite the well-documented benefits of culturally relevant teaching, many teachers report difficulty designing mathematics tasks that are both culturally meaningful and mathematically rigorous. Teacher education programs therefore play an important role in helping teachers develop the skills needed to design these kinds of learning experiences. This study examines how a fully online teacher education program, supported teachers in doing this work. This study is grounded in two primary frameworks. The first is culturally relevant pedagogy, which emphasizes three key goals: academic success, cultural competence, and critical consciousness. From this perspective, students' cultural knowledge and lived experiences are seen as valuable resources that can support meaningful learning. Within mathematics education, this framework challenges the idea that mathematics is culturally neutral and instead positions mathematics as a tool students can use to understand issues affecting their communities. The second framework guiding this study is culturally relevant, cognitively demanding mathematics task framework, or CRCD framework. This framework emphasizes mathematics tasks that are simultaneously mathematically rigorous, culturally meaningful, and oriented towards deeper understanding or transformation. Together, these frameworks guided both the design and analysis of the tasks examined in this study. Prior research consistently demonstrated the benefits of culturally relevant teaching practices in mathematics education. Studies show that when mathematics instruction reflects students' cultural context and lived experiences, students often demonstrate higher engagement and deeper conceptual understanding. For example, Gunstein's work illustrates how students can use mathematics to analyze issues such as income inequality and community access, developing both mathematical reasoning and critical consciousness. However, despite these benefits, many teachers struggle to design culturally relevant math tasks. Challenges Challenges often include uncertainty about how to connect mathematics to authentic community contexts while still maintaining strong cognitive demand. These challenges highlight the importance of teacher education programs that provide structured opportunities for teachers to design, revise, and reflect on culturally relevant mathematics tasks. This study uses a qualitative multiple case study design, following Yin's approach to case study research. Two secondary mathematics teachers enrolled in a fully online master's program were examined as individual cases. The two participants represented different teaching contexts. Amy is a white teacher working in rural Virginia high school, serving predominantly white working class students. David is a black teacher teaching in an urban high school, serving predominantly African American and Latinx students. The data sources included digitally submitted mathematics tasks, AI-supported planning artifacts, online reflections, and samples of students' work collected through the program's learning management system. These artifacts were analyzed using qualitative thematic analysis guided by the CRCD framework. Amy designed mathematics tasks that connected mathematics to students' interests, and local economic realities. For example, one task asked students to analyze statistical data comparing Marvel and DC superheroes, allowing students to apply statistical reasoning with a familiar cultural context. Another task, titled Income Discrepancies, asked students to use the system of equations to explore differences in income and economic decision making within their community. She also designed tasks related to direct and inverse variation using cost of living scenarios, as well as quadratic modeling tasks focused on housing affordability. Through peer discussion, instructor feedback, and AI-assisted brainstorming tools, Amy refined these tasks to increase cognitive demand and deepen the connection between mathematics and students' lived experiences. David's tasks focus more directly on community issues and social awareness. One task asked students to investigate whether the buildings in their school or community met ADA ramp slope standards, applying geometric reasoning to analyze accessibility and public policy. Another task focused on youth entrepreneurship, where students used linear equations to model business cost, revenue, and profit. These tasks position mathematics as a tool students could use to examine issues affecting their communities while still engaging in rigorous mathematical reasoning. Excuse me, y'all. Through the online learning environment, David engaged in multiple cycles of reflection and revision supported by instructor feedback and AI-assisted alignment checks. Both cases, teachers demonstrated meaningful growth in culturally relevant task design. Amy's task emphasized student interest and local socioeconomical experiences, while David's task emphasized community issues and social awareness. Despite these differences, both teachers maintained strong levels of mathematical rigor. Students were required to engage in mathematical modeling, data analysis, and complex reasoning. The online learning environment played a critical role in supporting this development. Through cycles of digital submission, peer feedback, instructor guidance, and AI-supported reflection, teachers refined their tasks and strengthened alignment between the mathematical objectives and culturally relevant context. This study highlights how online teacher education programs can support culturally responsive mathematics instruction through structured task design and reflective practice. The findings also illustrated the potential role of AI-supported planning tools in teacher learning. When used as assistive tools rather than replacement for teacher expertise, AI technologies can support brainstorming, alignment checks, and reflective thinking during the task design process. These tools may help teachers more effectively design mathematics instruction that is both rigorous and culturally responsive. In closing, the study highlights three key ideas. First, cultural relevance and mathematical rigor can coexist in mathematics classrooms. Second, community contexts shape how culturally relevant mathematics tasks are designed and implemented. And third, online teacher education environments supported by emerging technologies can provide powerful spaces for teachers to develop more equitable and responsive instructional practices. Thank you for your time, and we welcome any questions and discussions.